So we're going to be presenting building a petabyte scale video repository using software-defined storage. So first question in the crowd, does anyone feel like they know what software-defined storage is, just by show of hands? Wow, not a single person, okay. Because I was going to invite you up on stage to give the presentation. Okay, so we're going to talk about software-defined storage and what that means in the marketplace around that, and then we're going to spend the majority of the time talking about the RTL2 use case using software-defined storage in their broadcast environment. So the big change that's happening in the storage industry is similar to what happened when virtualization came around with servers, and what's happening in the network industry around software-defined networking. And the change that's happening is it's moving from a appliance-based type of marketplace, dominated by players like EMC and NetApp, into a marketplace where it's software that's decoupled from the hardware, where you can run the software on top of any x86 hardware, okay? So this is a $100 billion marketplace, data storage. It's a huge market, and this is a massive change that's finally hitting that part of the market, where it's hit other parts of the market previously. Scality is an example of software-defined storage. Different way to look at the marketplace and what's changing is, if you look at your own environments, and certainly the environments of our customers, you oftentimes see many, many tiers of storage, many, many different silos within that same environment. Okay, there's somewhat archaic classifications like SAN and NAS, object storage and tape. You often see these types of environments all at one company, but siloing the data all over the place. What we're seeing in the marketplace is a move towards a two-tier type of architecture, where you have very, very low latency storage, which is typified by converged infrastructures or flash types of products. And you have another tier of storage, which is represented by products like Scality, where it's massive scale, it's software-defined, and again, runs on commodity infrastructure. So to sum it up, when you're looking at software-defined storage, and as no one in this room has necessarily taken a hard look at it or has taken a glance at the types of technologies that are available, here's some things to look for. You want to look for a product that's truly decoupled from hardware, and the advantage of that is you're able to actually use either brand name servers or very commodity types of servers. So if you look at an Amazon or a Google, one of the things they've done over years is they wrote their own software to manage infrastructure at the storage layer, and they had servers designed purposely for them and built overseas, okay? The very manufacturers that build servers for HP also build direct for Google for Amazon. That's one of the big reasons why they've had the ability to scale and have the cost point they have. They've been able to leverage this type of hardware. Now everyone can leverage that type of hardware if you're able to run software like ours on top of it. Second thing is scale. So a lot of architectures that are out there with storage really were designed about 20 or 25 years ago. They were never meant for the kind of scale that we're looking at now when it comes to content distribution or creation. Okay, so you need to look at the actual architecture of the storage. You need to see if it can scale, if it can handle different types of workloads, and if it can handle different types of application interfaces. Okay, so a lot of the principles that went into designing an Amazon Web Services or Google have been baked into software, like ours. There's other products as well. Those are the kinds of considerations you need to make when you look at software-defined storage. Right? So with that, I'm going to hand it over to Hans-Josef to talk about the RTL2 environment. Hans?
Thanks, Leo, and hello to all of you. My name is Hans-Josef Lauer, and at RTL2 I'm responsible for the IT operations, means the maintenance of our 3 data centers, all the IT equipment of the users, all the network and security related hard and software, and last not least the user support. RTL2 is a part of the RTL Group, and the RTL Group is the leading European entertainment network. It has 49 TV stations and 29 radio stations in 8 different European countries. And they do this with about 10,000 people and create a revenue of nearly 6 billion euros. Okay, now coming to RTL2. RTL2 was founded in 1992 and is since March 1993 on air. We are located in Grunwald. This is directly on the city border of Munich in the south of Germany. RTL 2 has 180 employees and about 120 freelancers. Our audience share in 2040 was 6.3% in our targeted group aged 14 to 49 years. With this, we reached sales of nearly 750 million euros, and that is what we do. We are successful most of soap, daily soap like Berlin Day and Night or Cologne 50667, and we also are successful with US fiction like series like Game of Thrones or The Walking Dead. Okay, now coming to the IT department of RTL 2, we have 13 permanent workers and about 40 freelancers. With this team, we take care of more than 300 users and 3 data centers, about 150 servers with 2.5 petabyte of data. Our core business software called Bobby is self-deployed and also self-developed, and it's now in the 4th generation based on Java. What else we do? We cover the whole IT business of RTL 2. Okay, that's enough for the introducing part. Now I will come to our storage project. We started in the second half of 2030. This is how our old storage environment shows up. I think it's pretty common. It's grown over several years, and we have had there 2 data centers and 3 different SANs. The data were mirrored between the data centers, and also critical services like file print, mail, Bobby, Lauer's browsing are clustered with a cluster node in each data center. The SANs were for high-res files, low-res files, and databases and user files, which mean the group, shared, and personal volumes of the users. Of course, we had several servers with direct attached storage, and the normal connection to the network backbone was 1 gigabit, and that's also the same with the user connections with 1 gigabit. In the fiber channel backbone and the network backbone itself, we use 4, 8, or some 10 gigabit connections. Okay, so that was the old system, and it was running fine. But so perhaps you ask why we want to move. We face, of course, several challenges, and one of the hardest is the growing space requirements for storage due to the 4K production and also the creation of online content. What a hard blow for us also was that the proclamation of the MATE technology for the high-res SAN, which we use to make sure that only about 10% of the total 2,400 disks are spinning. And of course, the systems were older than 3 years, and that drives the maintenance costs up, and that got worse every year. Also, we have several different maintenance contracts with different vendors, which make it not easy, and the high complexity of the systems requires also a high knowledge to maintain them. So what were our requirements for the new system? We want to bring in the 10 gigabit network connectivity to fasten up the transfer time. And we also want to use standard IT hardware, no black boxes. We want for delivery purposes standard protocols like Samba or NFS or FTP. And we dream of a single storage for all kind of data. That results in a single vendor strategy. And of course, this vendor have to give us excellent support and a good partnership. So how was our way to Scality and the software-defined storage? When we begin in the second of 2030, we check out providers who fulfill our requirements, and we set up a first contact. Then we choose 3 of them for further negotiations and to make a proof of concept. At least due to the fact that 2 of the 3 offer Scality ring software only on different hardware. One was SGI, the other one was HP. We only have to do 2 proof of concept. The other one was with EMC and the IILeo platform. So how runs it with the proof of concept of Scality? We use 6 HP DL380 servers, which are very common. And there we installed the operation system, which is Red Hat Enterprise Linux in the version 6.5. Then the Scality engineers come by for 2 days on site and install the ring software and give us a first introduction of the system. After that, we have 4 weeks to test the system in kinds of speed and system fails. In this time, we get supported via the normal hotline of Scality, who give us hints or help us when things are not working like we think they work. After the 4 weeks, we set up a second meeting with Scality to review the proof of concept and discuss the open issues. After that, we make at RTL 2 a final decision how the new system setup will be and also the support matrix we need. And then go in final price negotiations with the 3 vendors. With this information, we go to the RTL 2 management and make a final decision that we go with Scality software and the HP hardware under it. So we ordered the things, and of course, both were delivered. And then we put in the 12 HP SL4540 servers, each with 60 hard drives, in 2 new racks, and installed the operation system. Then the Scality engineers come by for 2 days and installed the ring software. And as you see, we choose a different design. We choose a design with 3 data centers. That is because we want to bring down 1 complete data center for maintenance, and that will have no impact of the running systems. That is very fine for us. Then we need an additional day for fine-tuning the system and make some final tests. And then the Scality ring was quite fast ready to start. But as you guess, the work now begins, because we have to adjust our media asset management system to bring in the high-res data. We do this with a vendor with this S4M, Solutions for Media, and we need about 6 weeks for deploying and testing. After that, we can go productive with the high-res files, and that was the 21st of July last year. From this time, all new video files were stored and retrieved in the Scality ring. Then we begin with recreating the existing 350,000 high-res files. For that, we develop a new workflow for our Bobby software, which creates MD5 checksums before and after the transfer to make sure that that the file which come in the Scality ring is exactly the same as on the old storage system. That takes us another 2 months before we can start with the migration and the 1st of October. In February, we expand the ring with additional 6 SL4540 servers to a now total capacity of 4 petabyte. And that was amazing. The expansion was done remotely by the Scality guys and with no impact on the productive systems. That was really great. By now, we are testing the user data with a single group volume and also with some user volumes, which contains the redirection files of the operation systems. This is a little bit critical because they have a low latency, and we will have to look how it works out with the ring. Then we want to bring in the whole user data, and last not least, the low-res files and the more than 60 million thumbnails from the storyboards of the low-res files. But we hope to finish this by the end of the year. So what are the lessons we learned by now? First is that the proof of concept is absolutely necessary, because there was where we got that our dream that one storage for all kind of data won't come true. Of course, Scality told us that the software-defined storage isn't capable for databases, but yeah, that is where we saw it. So we have bought 2 small EMC VNX systems for the databases with a capacity of 50 terabyte. What we also learned was that adjusting external systems like the media asset management or also our Bobby system take a lot of time. And it's equal if you have an external vendor or you have your own development team. So you have to plan in this time to get it. Also, we come up with 2 technical issues over the time we use the software. That is the first one, that the SMB browsing is slow in the Scality ring. And that is where we get a direct user feedback, because when they click in the Explorer on a directory, they want to see the files direct in the same moment. And now it takes about 1 second before they get it. The second one is that we see that read access to the same directory with a second access node isn't possible yet. But both of those issues will be fixed in a new release of the software, which come out in the 3rd quarter of this year. So at the end of my session, I will come to the improvements we reached and to the next steps we take. At first, the 10 gig technology we brought in for the ring and the servers speed up the transfer times by about 10 times faster than the old systems. This is really great for us, because they get more and more streams we had to put out of the storage. Second is we have less complexity due to that we use standard IT hardware from HP, and we use very, very much, about 95 of our servers are HP branded, so we are common with this. And also that we are able to have standard protocols are nice for us. So we get more time for the new improvements we have to make for further requirements out of the business. Overall, we have also saw that the support of the Scality is very nice. We have showed up with them several times, and they are very quick, friendly, and qualified. And most of what we see is the next step is that we will deploy the 10 gig technology for all involved systems we use in this environment, and we will launch the Windows 2012 servers to participate from the SMB3 advantages. And last not least, we will deploy the new release of the Scality Ring software when it is available to solve the issue with the SMB browsing and also with the read and access restrictions with different nodes. So my last slide is, shows how our system will be at the end by this year. And you see we have the ring and only the two EMC SANs for the database part. So that was it from my part, and I hope I could give you some helpful information how we do it at RTL2. Thanks a lot for listening and have a great time here at the Streaming Media in New York. So thanks a lot and back to Leo.
Thanks, Hans-Josef. I think we're out of time. I will say that you can visit us at booth 220. We're also having a dinner after the event, so if you're interested in having more conversation about the software or speaking to Hans-Josef about the environment, you can join us there. Just come on up after the presentation. Thank you.